Okay, so we're just with a couple of simple examples. Simple, remember, simple doesn't mean easy. Simple just means less complicated than other things, but just to kind of get you clued into one of the values of quadratic functions and why it matters, we are going to do a couple maximization or minimization problems. Okay, because remember, as long as we know if a parabola is pointing up or pointing down, we know whether there's a maximum or a minimum. So this becomes one of the uses of it, especially in statistics and other areas. We can do that. So from this section, we've got problem 3.4, the first example. Let's see if I can make all this look good without being too distracting here. So let's see. All right. So let's put, all right, not too bad. Okay, so up there you can see the problem. If you're watching the video, then you got the page in front of you. So example 1 says this. We've got a farmer, so we are going to help a farmer out. What could be better than helping a farmer that wishes to enclose a rectangular region? Okay, so again, this is a simplified problem. I understand there's probably not a lot of farmers doing this, but you have to start somewhere learning how to apply these concepts. So just this kind of simplified problem. So a farmer wants to enclose a rectangular region. He has 120 feet of fencing laying around, and he wants to use his barn as one side of the enclosure. So what we're told is X is going to represent the length of one of the parallel sides. So let's stop, because that's a lot of words. Let's kind of draw what's going on to kind of help us. So here we go. This is our first example. So let's write that right here. What the problem has told us is we got this farmer. The farmer is going to use the barn, which is going to be red. I'm not good at drawing things, so I don't know what's going on here, what I'm doing anymore. Oh, I made it. I made it work. Good for me. So the farmer is using his barn as one side of this thing, and because he doesn't have enough fencing, so what this farmer wants to do is make an enclosure that comes out like this. Okay, so this is where you lose my drawing. Now we're in 2 dimensions, the barn's in 3 dimensions. I have a funny story about how bad at art I am. We're gonna put it on video right now. So when I was in 5th grade, I was in pottery class. Anybody ever have pottery class? Do they still do that? Yeah, I'm really old. So we had pottery class and we were supposed to make something for our parents, and all the kids were making ashtrays for their parents because people smoked back then. But I didn't want to encourage my parents to smoke. I wanted to encourage them to have good habits, so I tried to make a toothbrush holder for them. Yeah, so what a great kid I was. I wanted them to brush their teeth. So all the kids are getting back their ashtrays, right? And I did not have a toothbrush holder from the kiln. And the teacher came up and said, yours was so bad that I didn't even put it in the kiln. So there you go. I am not an artist. Here's another story, just since you're learning a little bit about the Perkster right here. My first class I ever taught when I was in college and graduate school was a Calculus 3 class. And so I had to draw all these 3-dimensional, I had to draw some boxes and I had to draw spheres and stuff. I couldn't do it. Like I was standing at the board and I had to cancel my first day of class because I could not draw. I had to go and have somebody help me draw all these things. So I know you're not so lucky. I'm not canceling the rest of class. I've adequately drawn a barn here. So whether you're interested or not in my stories, you heard them. So there we go. We'll have to edit this part out later. Okay, so here we go. So this part says that let X represent the length of one of the parallel sides. What that means, in case you didn't understand it the first time, is the farmer wants to know how far can I push my fencing out from the barn. And so what we're going to see as we go through the problem is, since the farmer has 120 feet of fencing, he wants to make an area, he wants to make the biggest possible area for his goats or pigs or whatever he's going to throw in there. Okay, so he wants to know how far out can he go from the barn that is going to give the maximum, the biggest area in there. That's why this is a maximization problem. You with me on what we're doing here? Okay, so we're going to follow the problem along. The first part A says, what is the length of the remaining piece of fencing in terms of X? So if I know, the variable's been defined for us, if I know that each of these sides is X, I want to know what is this side? What's an expression for this right here? Does anyone have anything to throw out? I mean, I'd be super impressed if you do. So I'm not totally expecting anything, but I want to give you a chance to throw something out if you have a thought. Okay, that's fine. I didn't expect it, so you didn't do anything bad. You're right where I thought you would be. How much fence are we told the farmer has? 120 feet total, right? How much fence did the farmer use on this side? X, whatever it is, 10, 20, I don't know, but X. So we're gonna deduct that from the total of 120. How much did the farmer use for this side? X. So we'll deduct that from the 120. So what is the expression that I have when I start off with 120 feet and then I deduct X and I deduct X more? 120 minus, not X squared. We're not multiplying these things. That's a common mistake. I'm glad you said it. I like to get these things out in the open. It's going to be minus 2X. We started with 120, and then we subtracted X amount for the left side, and then we subtracted X amount for the right side. That's why we have 2X there. We okay? I know this is a hard problem. I get it. Word problems are difficult. Okay, so I want to take our time. I want you to ask any questions you need to. Okay, B. That's the A problem right there. Let me put a little A there so that you know that's the answer. The B part says determine a function A. So we got A of X. That's my area function. Determine a function A that represents the area of the region in terms of X. Well, how do you find the area of a rectangle? Adding all the sides is perimeter. So if the word perimeter is used, you're going to add up all the sides. How do you find the area? How do you find the inside stuff? Base times height, length times width, whatever words you want to use there. So I'm going to multiply the length times the width. So I'm going to take that 120 minus 2X, that's the length, and I'm going to multiply it by the width, which is X. I'm going to simplify this just a little bit, just by distributing. And I'm going to put it in descending order so that I know what my A, my B, and my C are if we have to do anything like that. So X times negative 2X is negative 2X squared. X times 120 is 120X. Still doing okay? Again, I know this is difficult stuff, so we're going step by step. The problem you do in just a minute is going to be super similar to this, except the farmer is going to put a third side in the middle because he or she wants to keep the pigs and the goats or whatever separate from each other. Okay, so it's just going to change one little thing, and we'll go step by step through. All right, the C part to the problem says, what are the restrictions on X? Okay, what are the constraints? Well, this is quote unquote a real world problem. I know it's a super simple example, but we're dealing in the world, so there's some limitations. So the value of X, this is a fence. What does X have to be bigger than then? Bigger than 0. Yes, X has to be bigger than 0. The problem wouldn't make sense if X was equal to 0, meaning that there was no fence over there, because then you couldn't put anything in it. It wouldn't make sense if X was negative. What does that mean? Negative fencing, I don't know. So the X has to be bigger than 0. It has to be some positive value. You with me on where I got this from? Okay. All I'm saying is that this width has to be bigger than 0. That's where that first constraint came from. Now we can get the second constraint in the same way. 120 minus 2X, this bottom, that also has to be bigger than 0. It can't be negative, it can't be 0. So 120 minus 2X has to be bigger than 0. So let's go, we're going to solve that. I'm going to subtract the 120 from both sides, and I get negative 2X is bigger than negative 120. I'm going to divide both sides by negative 2, and I get X is less than 60. So that means the furthest out from the side of the barn that I can go is 60. Because if I go further than 60, I'm not going to have 100, I'm going to have more than 120 feet that I would need, and that was one of the constraints of the problem. So when you're asked, what are the constraints for our farmer? Well, this side has to be bigger than 0, and this side has to be bigger than 0. So this is how I'm going to summarize this. This means my values of x have to be bigger than 0. That's the lower bound. Can't be negative, can't be 0. Then they have to be less than 60. That's the upper bound. Last part to the problem, D part, says, what is the maximum area the farmer can enclose? I'm going to erase, does everyone have the C part written down? I'm going to erase that just because I've taken up a lot of space with this problem. So this is where we kind of answer the question that we've been worried about, is what's the maximum? So first off, how do I know that this has a maximum? What about this right here? This is my area function. We're asked, what's the maximum area? How do I know this even has a maximum? The negative. What does the negative tell me? It tells me that the parabola is flipped. It's pointing downward. So if the parabola is pointing downward, that means it comes to some maximum value. That's how I know. So if you did not have a minus here when you're doing the problem, and you see that I'm asking for a maximum, you know you did something wrong. Okay, you got to go back up and say, okay, I should have a negative here. It should be pointing down. All right, so what is that maximum area? Well, what I'm going to do is I'm going to find the vertex. Now, you're welcome to do one of two things. You can, if you really like using the completing the square and you want to do that here, fine. I'm going to use the vertex formula that we talked about, because all I care about, this is one of those situations, I don't care about the graph, I just care about what the vertex is, because that's where the maximum is going to happen. So remember, the vertex formula says I need negative b over 2a. That's going to be the value, the x value of the vertex. So what is the value of b of that parabola right there? 120, so that is negative 120 in the top because it's negative b. And then 2a, what's the value of a of that parabola? 2 times negative 2, there you go. So negative b is negative 120, and then 2a is 2 times negative 2. And when I do that, that is negative 120 over negative 4, and I believe that's 30 if I've done my division right. Now always be conscious of what you've been asked. We weren't asked how far can the farmer build out to get the maximum area. That would be 30 feet. The farmer can go 30 feet. We've just found that the x value that gives me the biggest area is 30 feet. But that's not what we were asked for. We were asked for what is the area. So what am I going to do with this number 30? I'm going to plug it in, yeah, just to find the y coordinate. The y is the value. So what is the area when the farmer builds out 30 feet away? Well, that is negative 2 times 30 squared plus 120 times 30. And remember, you got a calculator, so go ahead and use it. So 30 squared, I think that's 900 times negative 2 is negative 1800. And then 30 times 120, that's a couple of zeros, and it looks like a 3 and a 6. So the maximum area is 1800 square feet. So if that's too much for the farmer can choose to lessen x and and do whatever he wants. Okay, so we have just enough time. We got about 10 minutes left. So I'm going to give you, what we're going to do is we're going to go one step at a time just to make sure we're all on the same page with this next problem. So I'm going to give you about a minute or a minute and a half to think of each of these problems. So like I said, exercise 1 is super similar with just one change to the drawing. So exercise 1 says another farmer, because we just got a line of farmers that need mathematical help. That's what we're doing here. Another farmer wants to enclose a rectangular region bordering a barn. So again, we're going to use the barn with fencing in such a way as to create 2 separate pens. Suppose that x represents the length of each of the 3, I underlined it just for effect, 3 parallel pieces of fencing. This farmer, she has 600 feet of fencing available. So here's the first thing I want you to do. Don't worry about the A part yet. What I want you to do is draw the drawing. Draw the drawing that represents what we've just been asked to do. There's just one little bitty difference to your new drawing versus the old drawing. Okay, so what hopefully you've done, you've drawn a beautiful barn right there. And so we have our fencing. The only difference this time is this farmer is going to put in another parallel side so that we can put the pigs over here and we can put the cow that we have over there, okay, and keep them separate. We don't want them fighting. Okay. So each of these is X. We're going the same distance out. It's going to be a rectangle. Now we're ready. We're going to do these out of order. Okay, we're going to do the A, the B, the C, the E. Then we'll come back to the D part. We're going to set up the D part, and you can solve it later. All right. So what I want you to do, the A part. What is an expression for this long side of the rectangle? Okay. What's the expression? Don't shout it out. Let me give you 60 seconds. Write down what you think the expression for the long side of the rectangle should be. What's the total amount of fencing this farmer has? 600. How many sides are we deducting from that? Okay, so this expression should be, we start with 600 feet of fencing, and then we subtract 3x. Okay, there are 1, 2, 3 sides we're building on this. So far, so good? The B part, determine the area function. This is the same exact thing we just did. Okay, this middle segment does not complicate the area part. Okay, don't read into it too much. Okay, so what is the area function for this one? All right, once again, the area of a rectangle is just length times width. So the length of this rectangle is 600 minus 3x. The width of this rectangle is just x. So there's my area function. I'm going to do the same thing here I did on the last one. I'm going to distribute. I'm going to write it in descending order. So x times negative 3x is negative 3x squared. And then x times 600 is 600x. There's my area function. The C part. What are the restrictions on x? So same thing we did. It's in your notes. Follow along with what we just did a few minutes ago for the C part. All right, the first limitation has to do with the width. Okay, so the width has to be bigger than 0. We can't have a negative width or we can't have a no width. That wouldn't make sense for the problem. Then the second restriction is that the length has to be bigger than 0. So 600 minus 3x has to be bigger than 0. And when I solve this, I'm going to subtract the 600. So negative 3x is bigger than negative 600. Divide both sides by negative 3. And I have to flip the sign now. So x is less than 200. So that means this farmer, when she's building this, that means that the minimum amount she has to do is 0. And then the maximum distance away from the barn that she could build is 200. Because 200 and 200 and 200, that would be all 600 feet of fencing. So you'd have to have a really thin cow, but that's the maximum that she could go. Then I'm going to skip to the E part to the problem. The E part to the problem, what is the maximum area the farmer can enclose? So this is the same as the last thing we did in the previous problem. What is the maximum area this farmer can enclose? All right, so this entails finding the vertex, and you're doing the busy work for that. So I'm going to get started. First off, I know there's a maximum because there's a negative in front of the x squared. So that means this parabola is pointing downward. So it's going to come up to a maximum point. So what I'm going to do is I'm going to use the vertex formula to figure out what that maximum point is. So negative b, well, the value of b is 600. So negative b is negative 600. 2 times a is 2 times the value of a, which is negative 3. So negative 600 divided by negative 6, that's 100. That's the x value. So again, if you were asked, how far out can the farmer build from the barn for the maximum area? You've answered it. The farmer can go out 100 feet. So each of these lengths can be 100 feet to get the maximum of the rectangle. But what we're asked is, what is the maximum area? So I'm going to put 100 into my area function. And so 100 squared is 10,000, so that's negative 30,000. 600 times 100 is 60,000. And so what we end up with is the farmer can enclose a maximum of 30,000 square feet. One final thing, and then I'm just going to mention something about one of the problems on the back page, and then you are free of me. Test on Wednesday, office hours. I'll be here early for you guys. Email me if you have anything that's urgent. The last thing says we're going to do the D part. So this was the E part. I mislabeled it. Sorry. The D part says, find what dimensions for the total enclosed region would give an area of 22,500. So in this case, in the D part, our farmer doesn't care about the maximum area. Our farmer wants to know, I need this specific area. I need 22,500 specifically. So here's how you do a problem like this. Here's my area function. I want to know when my area function is specifically equal to 22,500. Then all you're going to do at this point is you're going to get everything either on the left or right and use the quadratic equation to solve it. And that's going to tell you what the value of x is. That's going to give you this specific value of the area. All right, before you go, I've got 30 seconds left. I just enough time. If you have a question or two, you're welcome to stay after, that's fine. Exercise 3 on the back page. There will be other problems in the homework aside from the area problems that you can do. There are other problems like exercise 3 where a function is given to you. So that function is the height of a golf ball at a particular time. And so it's the same thing. If you're asked to find the maximum height of the golf ball, you're just finding the vertex. That's all the maximization problems or minimization problems are, is finding the vertex. So you'll be able to do some of the other problems in the homework. I'm going to adjust it so that you don't have to do get 70% right. I'm going to lower that so that you'll be able to take the quiz. And then just remember what I told you about the quiz, and all will go well for you. So I hope you have an amazing rest of your day. It was great to see you. Thanks for being here.